All right, let's go. Number 10, the universe that deletes itself when you stop looking. In 1927, physicist Werner Heisenberg published a paper that should have ended the debate about objective reality before it even began. His uncertainty principle didn't just say we struggle to observe things accurately. It said that certain physical properties don't exist in a definite state until the moment of observation, not hidden from us, not too small to measure, simply not there. Physicists spent decades trying to find a workaround. Maybe particles have hidden instructions pre-programmed before measurement. Maybe the uncertainty is ours, not theirs. In 1964, physicist John Bell designed a theorem that could settle the question once and for all. If hidden variables existed, measurements on entangled particles would obey a specific statistical limit. In 1982, Alain Aspect tested it in the laboratory. The limit was violated. There are no hidden variables. The particle genuinely has no definite state until something forces it to choose. What makes this unbearable is the logical consequence nobody wants to say out loud. If particles have no definite properties between observations, then the matter those particles compose has no definite properties between observations. The chair you're sitting on exists as a resolved state only because you and the electromagnetic forces of your body are continuously interrogating it. The room behind you right now, the street outside, the planet beneath you, none of it is required by physics to exist in a specific configuration while nothing is measuring it. The universe doesn't maintain itself in your absence. It waits. And the most disturbing question isn't what reality looks like when nobody's watching. It's whether looking is the only thing that makes it look like anything at all. Number 9, the speed limit that was never meant for you. Every physics textbook presents the speed of light as a fundamental constant of nature. 299,792,458 meters per second. The universal speed limit. Nothing with mass can reach it. Nothing at all can exceed it. The equation is clean. The derivation is elegant. And for over a century, every experiment has confirmed it without exception. But in 2019, a group of theoretical physicists at the Perimeter Institute published work that raised a question the textbooks don't address. Why this number? The speed of light isn't derived from any deeper principle. It isn't calculated from other constants. It appears in the equations as an input, a value that was set, not discovered. Physics can tell you everything the speed of light does. It cannot tell you why it is what it is, or why there is a maximum at all. In a universe of pure physics, there is no reason for a speed limit to exist. Space should allow propagation at any rate. Energy should be transferable at any velocity. The only systems that impose absolute maximum transfer rates are computational ones. Processing architectures have clock speeds. Information networks have bandwidth caps. Simulated environments have a maximum rate at which adjacent elements can update each other. The speed of light isn't just a limit on how fast you can travel. It's a limit on how fast anything in the universe can affect anything else. That is precisely what you would engineer into a system if you needed to prevent runaway cascades from overwhelming the underlying computation. We spent a century treating the universe's speed limit as a law of nature. We have never seriously asked whether it might be a system constraint placed there before a single particle was allowed to move. Number 8, the coordinates that shouldn't exist. In 2013, the European Space Agency's Planck satellite completed the most detailed map ever made of the cosmic microwave background radiation. The oldest light in the universe, emitted 380,000 years after the Big Bang. Scientists expected to find what standard cosmology predicted: a smooth, statistically uniform glow with minor random fluctuations, carrying no meaningful large-scale structure in any particular direction. Instead, the data showed something the team initially refused to publish. The temperature patterns of the entire observable universe align along a single axis, not approximately, not statistically suggestive. The largest scale features of the CMB, spanning billions of light years, line up as though the universe has preferred direction. Cosmologist Kate Land at Oxford named it the axis of evil, not for dramatic effect, but because its existence is genuinely incompatible with the standard model of cosmology that the entire field is built upon. The probability of this alignment occurring by random chance is less than 1 in 1,000. The same data reveals a hemispherical asymmetry. One half of the observable universe has measurably different temperature fluctuations than the other. There's also a cold spot spanning billions of light years with no accepted physical explanation. A universe born from a random quantum fluctuation and expanded symmetrically in all directions should have no preferred axis. It should have no hemisphere that differs from another. It should have no address, no orientation, no coordinates relative to anything outside itself. The axis of evil doesn't just challenge our models. It suggests the universe is oriented relative to something. The question that cosmologists have avoided for over a decade is the only one that actually matters. Oriented relative to what? Number 7. The number that should be 0. In the 1990s, astronomers measuring the expansion rate of the universe made a discovery so unexpected that they spent years checking their instruments before publishing. The universe isn't just expanding, it's accelerating. Something is pushing space itself apart at an increasing rate. They called it dark energy, and they assigned it a value, the cosmological constant. Here's the problem. When physicists calculate what the cosmological constant should be based on quantum field theory, our most precisely tested framework for understanding the behavior of matter and energy, they get a number. When astronomers measure what it actually is, they get a different number. The discrepancy between the theoretical prediction and the observed value is 10 to the power of 120. That is a 1 followed by 120 zeros. It is the largest error in the history of scientific prediction. Physicist Roger Penrose has called it the most embarrassing number in physics. But embarrassment understates what this number actually means. It means that either quantum field theory, the framework that predicts the magnetic moment of the electron at 12 decimal places of accuracy, is catastrophically wrong about the vacuum energy of space, or something is actively suppressing the cosmological constant to a value nearly identical to 0 without reaching 0. Random processes do not produce fine-tuning to 1 part in 10 to the 120. Chance does not select a number from an effectively infinite range and land within a razor-thin margin of a specific target. The only mechanism known to produce that kind of precision across that kind of range is deliberate selection. Someone or something needed the cosmological constant to be almost exactly what it is, because any other value produces a universe where nothing we can see ever gets to exist. The precision isn't a coincidence. Coincidences don't have 120 zeros. Number 6, the signal that knew when to stop. On August 15, 1977, at 11:16 p.m., a radio telescope at Ohio State University detected a narrowband transmission from the direction of the constellation Sagittarius. It lasted 72 seconds, the exact maximum duration the telescope could observe a fixed point in the sky as the Earth rotated beneath it. It arrived at 1,420 megahertz, the hydrogen line frequency that physicists had identified decades earlier as the most logical channel for deliberate interstellar communication. It was 30 times louder than the background noise of deep space. Astronomer Jerry Emmons circled it in red ink and wrote one word: wow. The signal has never repeated. Not once in nearly 50 years of targeted follow-up observations, using increasingly powerful equipment aimed at identical coordinates. Every natural explanation that has been proposed has been tested and found insufficient. Comets, pulsars, terrestrial interference, satellite reflections. None of them account for the signal's specific frequency, intensity profile, and narrowband characteristics simultaneously. What most analyses of the WOW signal overlook is its most significant feature: the timing. The signal arrived during a 72-second observation window and lasted exactly as long as that window allowed. It didn't cut off mid-transmission. It didn't fade. It appeared at the start of the window and was gone by the end of it, as though whatever sent it knew precisely how long it had. A natural radio source doesn't calibrate itself to an observatory's rotation schedule. A beacon doesn't transmit once and fall permanently silent. The behavior of the WOW signal doesn't match communication. It matches a scan, a brief, powerful pulse sweeping across a region of space, logging whatever is there, and moving on. We were logged. Whatever filed that report has never needed to look at us again. Number 5, the visitor that accelerated away from nothing. In October 2017, the Pan-STARRS telescope in Hawaii detected an object crossing our solar system on a trajectory that could only have originated from interstellar space. The first such visitor ever confirmed. Astronomers named it Oumuamua, Hawaiian for scout. Its shape was unlike any natural object in the solar system. Estimates place its length-to-width ratio at approximately 10:1, a flat, elongated form that tumbled through space in a complex rotation pattern inconsistent with any known formation process. Its surface reflected light at levels inconsistent with rocky or icy composition. These anomalies were noted, flagged, and quietly set aside. Then, as Oumuamua was leaving the solar system, it accelerated, not due to gravitational interaction with any known body, not due to outgassing, the standard mechanism by which comets experience non-gravitational thrust, because Oumuamua showed no coma, no gas tail, and no spectroscopic signature of volatile material release whatsoever. The acceleration existed without any detectable source. Harvard astronomer Avi Loeb published a peer-reviewed paper proposing the properties were consistent with a light sail. The scientific community's response was to propose alternative explanations, each of which accounted for some of Oumuamua's anomalies while failing to account for the others. No single natural model has ever explained all of its observed properties simultaneously. We had 11 days of observation before it passed beyond the range of every instrument we have. It came from outside the solar system, violated the expected behavior of every natural object class we know, accelerated by an undetected mechanism, and disappeared into interstellar space before we could determine what it was. The most unsettling detail isn't the object itself. It's the name astronomers chose before they knew what it was. Scout. Sometimes the first instinct is the right one. Number 4, the galaxy that broke the formation model. In 2018, astronomers using the Hubble Space Telescope identified a galaxy designated NGC 1052, DF2, located approximately 65 million light-years away. It was a routine addition to an expanding catalog, until the mass measurements came back. NGC 1052. DF2 contains almost no dark matter. In a universe where dark matter is the invisible scaffolding around which every galaxy assembles, where its gravitational influence is what allows ordinary matter to clump into the structures we observe, a galaxy-sized object with essentially none of it should not be able to exist in any stable form. The standard model of galaxy formation has no mechanism for producing what the data showed. A second galaxy, NGC 1052 DF4, was identified with the same anomaly. Then a third. Astronomers now call them ultra-diffuse galaxies, and the catalog of dark matter-deficient examples has continued to grow. Each one is a galaxy-scale object that exists in direct contradiction to the process by which galaxies are supposed to form. The prevailing response has been to investigate whether dark matter could have been stripped away through tidal interactions with neighboring galaxies. The math for this explanation is difficult. The timescales don't work cleanly. The distribution of these objects doesn't consistently place them near candidates capable of the required stripping. What these galaxies actually demonstrate is narrower and more troubling than the debate around them suggests. Dark matter, the substance that accounts for 27% of the total mass energy content of the universe, that has never been directly detected, that is inferred entirely from its gravitational effects, apparently comes in quantities that can range from enormous to nearly absent in objects of comparable size. We don't know what dark matter is. We don't know why some galaxies have almost none of it. And the model we use to explain how every structure in the observable universe formed depends on it behaving in ways that these galaxies prove it sometimes doesn't. Number 3, the mathematics that knew before we did. In 1915, Albert Einstein published the field equations of general relativity. The mathematics predicted that the universe should be either expanding or contracting. Einstein considered this a flaw. He introduced a cosmological constant to force the equations to produce a static universe, because a static universe was what observation seemed to confirm. He later called it his greatest mistake. In 1929, Edwin Hubble confirmed the universe is expanding. Einstein's original equations were right. His correction was wrong. In 1928, Paul Dirac was attempting to reconcile quantum mechanics with special relativity. His equation produced two solutions where physics expected one, a positive energy electron, and a negative energy counterpart that appear to be its mirror image. Dirac initially tried to explain away. In 1932, Carl Anderson detected the positron in a cloud chamber. Dirac's mathematics had predicted antimatter 4 years before anyone knew antimatter existed. In 1916, Einstein's field equations predicted gravitational waves, ripples in the fabric of space-time produced by accelerating massive objects. The prediction was considered untestable. For a century, it remained a mathematical artifact, a consequence of the equations that might not correspond to anything physical. In 2015, LIGO detected them for the first time. The pattern is not occasional. It is consistent across the history of theoretical physics. Mathematicians derive structures through pure logic with no reference to physical observation, and those structures turn out to describe reality with more precision than experiments designed specifically to investigate it. Eugene Wigner called this the unreasonable effectiveness of mathematics and identified it as a mystery requiring explanation in 1960. No satisfying explanation has been produced in the 60 years since. In a universe that exists independently of any underlying code, mathematics should approximate reality. It should not predict it before the reality arrives. Number 2, the void that measures 300 million light-years of nothing. Large-scale surveys of the universe's structure have revealed that matter is not distributed evenly across space. Galaxies cluster into filaments and walls, with enormous empty regions between them. This is expected. Gravity gathers matter over time, creating structure, and the voids between that structure are a natural consequence of the same process. Standard cosmology predicts their existence and models their formation. In 2007, astronomers analyzing data from the NRO VLA Sky Survey identified something outside those predictions. A region of space in the constellation Eridanus spanning approximately 300 million light-years in diameter that contained almost no galaxies, no detectable dark matter, no gas clouds, and no radiation above background levels. Not a void in the ordinary sense. Ordinary voids have structure at their edges and scattered matter within them. The Eridanus supervoid was empty in a way that standard models could not generate. The probability of a void this size forming through gravitational processes alone, within the age of the universe, is so low that several cosmologists independently classified it as statistically incompatible with the standard model of cosmic structure formation. Laura Mersini-Houghton at the University of North Carolina proposed an explanation that the cosmology community has spent years trying to rule out without success. The supervoid is a gravitational imprint of a neighboring universe, pressing against our own from outside the boundary of observable space-time. If that interpretation is correct, the void is not an absence. It is a footprint. Something pressed against the fabric of our universe from outside it during its earliest moments and left a 300 million light-year bruise in the structure of space that we are only now large enough to see. We've been staring at the mark left by something outside the universe for decades. We called it empty because we didn't have a word for what it actually is. Number 1, the moment before the first moment. Every origin story for the universe begins at the same point, the Big Bang, the moment, approximately 13.8 billion years ago, when the observable cosmos emerged from an extraordinarily hot, dense state and began expanding. Before that moment, physics has nothing to say. The laws of nature, as we know them, break down at the initial singularity. Time itself, in the framework of general relativity, does not extend backward past that point. The question of what came before the Big Bang is, by the standard account, not a question with a physical answer. It is asking what is north of the North Pole. In 2010, physicist Roger Penrose and mathematician Vag Grzadian published an analysis of the cosmic microwave background that found something the standard Big Bang model explicitly forbids. Concentric rings of anomalously low temperature variance, regions where the CMB is smoother than its surroundings in patterns that repeat concentrically, centered on specific points across the sky. These rings, Penrose argued, are the echo signatures of supermassive black hole collision events from a previous universe that existed before our own. His model, conformal cyclic cosmology, proposes that our universe is one in a series, that the heat death of a previous universe, where all matter has evaporated and only massless particles remain, is geometrically equivalent to a new Big Bang, and that the cycle repeats. The The rings in the CMB are the gravitational echoes of the previous cycle bleeding through into ours. The implications are not abstract. If Penrose is correct, the universe didn't begin. It continued. The Big Bang was not the start of existence. It was a transition, one moment in a sequence that extends backward through cycles we can never observe and forward through cycles we will never survive to see. The cosmos doesn't have an origin. It has a rhythm. And the most disturbing part of that rhythm is what it says about everything inside it. Every star, every civilization, every mind that has ever formed in any cycle is a temporary pattern in a process that was never started and will never end, arising, persisting briefly against entropy, and dissolving back into conditions that will see the next beginning. You are not the product of a universe that was made. You are a fluctuation in a universe that simply has always been making itself. And somewhere in the rings burned into the oldest light we can detect, the last massive objects of the universe that died before ours was born left their mark on our sky. We are not the first. We are not the last. We are somewhere in the middle of something that has no edges, and we have just barely developed the instruments to suspect it. If you want to see more videos like this, click the video on screen now and make sure to subscribe.